Congruence of triangles. SSS test, SAS test and ASA test. We know how to establish the correspondence between congruent parts of triangles. We also know how many different correspondences exist for the different types of triangles. If two scalene triangles are congruent, they are congruent for only one correspondence. If two isosceles triangles are congruent by one correspondence, they are congruent by one other correspondence too. If two equilateral triangles are congruent by one correspondence, they are congruent in every other correspondence. What we need to know is how to find out whether two triangles are congruent. We can't keep tracing triangles and cutting them out to superimpose on each other. Come on, we are in the 7th standard now. We need to check for congruence like the real mathematicians do. Let me tell you a secret. It's actually quite easy. There are just 3 simple tests. If any one works, the triangles are congruent. If all 3 fail, the triangles are not congruent. As simple as that. SSS test, which means side side side, SAS test, which means side angle side, ASA test, which means angle side angle. So, you check 2 triangles by these tests. If you get a yes for any one test, then you can declare the triangles to be congruent. First, let us look at the SSS test. You already know that SSS means side side side. That just means that if you have 3 sides of one triangle equal to 3 corresponding sides of another triangle, the triangles are congruent. That seems pretty obvious, doesn't it? Well, I told you it was all very easy. Let's look at how this test is expressed in the mathematics way. Congruence of triangles by SSS test. If 3 sides of one triangle are congruent with the corresponding 3 sides of the other triangle, the 2 triangles are said to be congruent by SSS test. According to the correspondence, ABC corresponds to XYZ. Now we observe that side AB is congruent to side XY, side BC is congruent to side YZ, and side AC is congruent to side XZ. Therefore, triangle ABC and triangle XYZ coincide exactly. So, triangle ABC is congruent to triangle XYZ by SSS test. Now, let us look at the SAS test. You already know that SAS means side angle side. That just means that if you have 2 sides and the angle between those 2 sides equal to 2 corresponding sides of another triangle and the angle between those 2 sides, the triangles are congruent. Just remember that the congruent angle can't be just any angle. It has to be the angle between the 2 congruent sides. Let's look at how this test is expressed in the mathematics way. Congruence of triangles by SAS test. If 2 sides and included angle of one triangle are congruent with the corresponding 2 sides and the corresponding angle of the other triangle, the 2 triangles are said to be congruent by SAS test. According to the correspondence, ZXY corresponds to RPQ. Now, side XY corresponds to side PQ, side ZY corresponds to side RQ, and angle XYZ corresponds to angle PQR. Therefore, triangle XYZ and triangle PQR coincide exactly. So, triangle XYZ corresponds to triangle PQR by SAS test. The third test is ASA test. You already know that ASA means angle side angle. That just means that if you have 2 angles and the side between those 2 angles equal to 2 corresponding angles of another triangle and the side between those 2 angles, the triangles are congruent. Just remember that the congruent side can't be just any side. It has to be the side between the two congruent angles. Let's look at how this test is expressed in the mathematics way. Congruence of triangles by ASA test. If two angles and the included side of one triangle are congruent with the corresponding two angles and corresponding side of the other triangle, the two triangles are said to be congruent by ASA test. DEF is congruent to PQR. Therefore, angle DEF is congruent to angle PQR. Angle DFE is congruent to angle PRQ. Side EF is congruent to side QR. Therefore, triangle DEF and triangle PQR coincide exactly. Therefore, triangle DEF is congruent to triangle PQR by ASA test. Once you have proved that two triangles are congruent, that means for a certain correspondence they are exactly identical to each other. Triangle ABC is congruent to triangle PQR. AB is equal to PQ, BC is equal to QR, AC is equal to PR. That means the corresponding sides are equal. When we use this reason in our solution, we call it corresponding sides of congruent triangles and write it as CSCT for short. Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. It also means that corresponding angles are equal. When we use this reason in our solution, we call it corresponding angles of congruent triangles and write it as CACT for short. By which test can you declare the triangles to be congruent? Look at the given information and let's make some notes in the diagram. AC is congruent to DF, so make some mark on AC, maybe a single line across it. Make the same mark on DF. That helps you quickly see that they are congruent sides. Do this for all the other given information too. AB is congruent to DE, BC is congruent to EF. What congruence do you see? Side, side, side. So you can say that the triangles are congruent by SSS test. So the diagram marks help. In geometry, for all such questions, when you start solving, draw the diagram and then make notations and then proceed. You will get the answers quickly. Now, you've solved this in your head. Let's see how to write this properly when we solve. There is a format to solve such questions. Write the statement and then the reason for the statement. Write this in two separate columns and be very neat in your work. And remember, before you start writing the solution, you must have the solution in your head. So observe, think, and solve it in your head before you hit the paper. Now we have solved it in our head. So let's begin with the paperwork. So we have the diagram and the two columns. The first one is for statement and the second one is for reasons. When you write something in the statement column, you should have a reason for it. In mathematics, we must have a reason for every single thing. Let's start. Segment AC is congruent to segment DF, that is given. Segment AB is congruent to segment DE, which is given. Segment BC is congruent to segment EF, which is given. So, triangle ABC is congruent to triangle DEF by SSS test. Hence, proved. Let's take a look at another one. So, let's look at the diagram. We are given information that angle T is congruent to angle N. Let's mark that in the diagram. For SAS test, we need to have two sides and the angle within those two sides to be congruent. Since we already have the angle, we need the two sides that enclose the angle to be congruent. Therefore, if we have to use the SAS criterion, segment AT needs to be congruent to segment PN and segment RT needs to be congruent to segment EN. In the given figure, AB and CD are equal chords of a circle with a center O. Prove that triangle AOB is congruent to triangle COD. We have to show that triangle AOB is congruent to triangle COD. What do we already know about these two triangles? Let's see. We know that AB is congruent to CD as that is already given. We can see that OA, OB, OC and OD are all congruent to each other as they are radii of the same circle. We know that in a circle, all radii are equal. So let's mark that. Then we can prove the triangles are congruent by SSS test. Okay, so we have solved it in our head. Now let's do it on paper. In triangle AOB and triangle COD, AB is congruent to CD, which is given. AO is congruent to CO, which is the radii of the same circle. OB is congruent to OD, which is the radii of the same circle. Hence, triangle AOB is congruent to triangle COD by SSS test. Hence, proved. Let's take a look at another one. In an isosceles triangle ABC, AB is equal to AC. If D and E are the midpoints of AB and AC respectively, prove that CD is equal to BE. We have to show that CD is congruent to BE. Locate this in the diagram first. What do we already know about this figure? Let's see. We know that AB is congruent to AC as that is already given. We know that D and E are the midpoints of those sides. So AD and DB are congruent. AE and EC are also congruent. And these are congruent to AD and DB since this is an isosceles triangle. Now you want to prove that CD is congruent to BE. They seem to be corresponding sides of triangle DCB and triangle EBC. If we can prove that these two triangles are congruent, then we can get the answer. How can we prove congruency? We know that DB is congruent to EC. We know that BC is congruent to BC as it is the common side. So we have information on two sides. We can then use the SSS test by proving that DC is equal to EB. Or we can use the SAS test by proving that angle ABC is equal to angle ACB. But wait, those are the base angles of the isosceles triangle, so they are equal. Okay, so we have solved it in our head. Now let's do it on paper. AB is congruent to AC, which is given. AD is congruent to DB as D is the midpoint of AB. AE is congruent to EC as E is the midpoint of AC. Therefore, AD is congruent to DB is congruent to AE is congruent to EC based on all of the above. Call this equation 1. In triangle DCB and triangle EBC, DB is congruent to EC from equation 1. BC is congruent to BC, reflexivity. Angle ABC is congruent to angle ACB as these are the base angles of isosceles triangle. Therefore, triangle DCB is congruent to triangle EBC by SAS test. Hence, CD is congruent to EB. Corresponding sides of congruent triangles written as CSCT. Let's take a look at another one. In the given figure, PQRS is a quadrilateral. If segment QS is the angle bisector of angle PQR and angle PSR, show that triangle PQS is congruent to triangle RQS. Also prove that PS is equal to RS. We have to show that triangle PQS is congruent to triangle RQS. Locate this in the diagram first. What do we already know about this figure? Let's see. We know that QS is the angle bisector of angle PQR and angle PSR. That means angle PQS is congruent to angle SQR. That also means that angle PSQ is congruent to angle QSR. Now, to show that triangle PQS is congruent to triangle RQS, what do you need? You need two angles, so you can try for ASA test by showing congruence of the side in between. But wait, that's a common side, so it will be congruent to itself. Great, so let's do it on paper. In triangle PQS and triangle RQS, angle PQS is congruent to angle SQR as QS is an angle bisector of angle PQR. Angle PSQ is congruent to angle QSR as QS is an angle bisector of angle PSR. QS is congruent to QS, reflexivity. Therefore, triangle PQS is congruent to triangle RQS by ASA test. We also have to prove that PS is congruent to RS. This is PS and this is RS. Those are just corresponding sides of congruent triangles. So it's done. Just write PS congruent to RS and in the reason write CSCT. Show that triangle AMP is congruent to triangle AMQ. First, read the question and understand what is it that you have to do. You have to show that triangle AMP is congruent to triangle AMQ. The first statement says PM is equal to QM. How do we know this? Because it is given. So write given in the reasons column. The next statement says angle PMA is equal to angle QMA. How do we know this? This is given too. We can see it from the markings in the diagram. So we write given in the reasons column. The next statement says AM is equal to AM. Look at this in the diagram again. It's the same segment, so obviously it is equal to itself. It's called reflexivity. You can write reflexivity as the reason for this one. Now the next statement is triangle AMP is congruent to triangle AMQ. What is the reason for that? We have a side, an angle, and a side. The angle is included in the sides. What test is this? This is the SAS test. So we write SAS test as the reason there. And with that, you have completed solving this question. Did you understand SSS test, SAS test and ASA test? Yes!
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.